Hey guys, welcome to the third episode of Home Automation at Home, where I show you guys how to build your own home automation systems for just a fraction of the cost of the available systems out there. So what I have for you guys today is the beginnings of a home monitoring platform. So this is a Teensy development board connected to an ESP8266 through a little serial breakout board. And the ESP module is basically going to be a conduit to communicate with the Teensy. And the Teensy will be doing all of the heavy lifting of actually flipping pins on and off and doing anything like that. So what I have is a set of lights that are going to monitor our temperature and a light that monitors a door, a fake door. And up on the top here, we have an ESP, we have two ESP modules. One of them is connected to a temperature sensor, and the other is connected to a little reed switch. Now, a reed switch is basically a switch that is actuated not by flicking it with your finger, but by the presence of a magnetic field. So these kinds of switches are normally the kind of switches that you see on door sensors for security systems. That's basically, you have the reed switch on the outside of the door, on the door frame, and then a small magnet that is on the door itself, and when the door opens, the switch is released, and that can be detected as the door being open. So that's what we have over here, and over here this is a DS18B20 Dallas temperature sensor. And both of these units are not connected. They're communicating via MQTT from Wi-Fi to this guy here. And this guy is then communicating back to here, and he monitors all of it. So that's basically what we're building today. And as you can see, it's actually up and running. So I have a little magnet here. And if I bring it close up, it detects that the door is closed. And if I take it away, the light turns on, telling me that the door is open. And I'll show you guys a picture of what this looks like in a real door situation as well. And on the left, we have our little temperature sensor, and I got three LEDs, blue, green, and red. And the blue obviously indicates that it thinks it's cold in the room. And green is whatever your mid-range temperature is. And red is your high temp. So maybe if I hold this little guy, we'll see it change. Alright, that doesn't seem to be doing it. My fingers are just too cold, so I have something a little bit warmer, a soldering iron. Let's see if that will make it change. Oh, there it is going green. Oh, and finally we have red. So you can see, well, it's pretty cold in here, so it didn't want to heat up very quickly. But there you have it. You can see that it is actually sensing the temperature. And those colors and what they mean are all completely user configurable in code. So it's pretty easy to make it work. And there we have it going back down as its temperature is dropping. So let's get into it and check out the code that makes all of this run. There's actually a fair amount of code. There are a total of 4 microcontrollers here. So let's check it out. Alright, so here we are at the Arduino IDE. So the first piece of code that I wanted to go over was the code for the ESP module that is connected to the Teensy. So I've named this ESP conduit. And it's a serial conduit. It's watching for MQTT messages, and when it gets a message, it's processing it and basically spitting out a tiny little serial packet that is going to the Teensy. So just like all the other things that we've done with MQTT so far, we have the ESP Wi-Fi and PubSub client libraries. And we have our MQTT server that you need to fill in, your SSID, your Wi-Fi network name, your Wi-Fi password. And we have 2 topics that we wanted to subscribe to. The door topic, so this is the topic that we'll be watching for changes on our door state being open or close. And this is the temperature topic, so this is the one that's monitoring for changes in temperature. So we create our Wi-Fi client and our server, and we start up our serial line. Now it does matter, this is important, to note your serial speed. So I'm using 115200. You're going to want to make sure that you match that on your receiving module, on your Teensy. So then we begin our Wi-Fi subsystem, and we attempt to reconnect. So we've seen this before. Create a unique name from our MAC address, and in here we just attempt to connect. We wait for connection. Once we're connected, we attempt to connect to our MQTT broker, and when we do, we subscribe to our 2 topics. Not too hard. Our loop, again, it's pretty simple. We sit here and we make sure that we're connected every time through the loop. If not, we attempt to reconnect. We run our MQTT client loop, and we give some delay for the ESP to do Wi-Fi functions. Our callback is where the majority of our code is this time. So we've seen this before. We convert our topic to a string rather than a character array. And in previous videos, this hasn't really been all that useful, but we're about to see it be useful right now. So then I create a little byte to send, and this will be the payload for what's going to be sent over the serial line to the Teensy. And then we have 2 if statements. And the first one is basically doing a string compare, string equals, to our door topic. And if those 2 match, we run the code to deal with handling the door opening or closing. And then we have the same statement basically asking whether the topic was actually equal to temp topic. So this is where converting our car pointer topic here to a string is actually really useful, because it lets us use string compare functions and look at it like a string rather than just an array of characters. It's just easier to deal with in this form. So when we get our door topic, when that's the message that's most recently come in, we look at if the payload, the 0th payload, so the first entry in our payload, was either a 1 or a 0. And if it was a 1, we set our payload to be sent to the Teensy, the byte to send, to a 1. And if it was 0, we said it's a 0. And then we have 2 little serial write functions. So our packet consists of basically 2 bytes, so a header, which in this case is set equal to D for door, and our payload. So this is the byte to send, so it's either going to be a 1 or a 0. So this will just send 2 bytes to the Teensy and assume that it gets them. I'm not doing any error checking here. It's all hardwired. I'm just not going to worry about that. And we send those 2 bytes, and it handles flipping the LED on and off. And then we have our temp topic over here. So this is if we've received a message from our temperature node. And what it does is it takes our byte to send and sets it equal to our payload. So we're actually just sending the raw binary of whatever the temperature is. We're not actually sending it in character form. And then we write T for temperature. That's our header for this one. And our byte to send is our current temperature. Now, this does have the limitation of you can only send 1 actual byte at a time, and if you need to send a number that's more than 255, well, you're going to have to modify this code a little bit. But it gives you an idea of how to use the ESP8266 as basically an MQTT conduit. Now let's take a look at the Teensy code. We've now seen how the ESP module communicates with the Teensy, so let's take a look at the code that's actually running on there. So we have our temperature pins that we define up here. So low temp pin 14, mid 13, high 12, and we have a door pin, so that's pin 10. Pretty simple. And we set all of our output pins as outputs, all of our LEDs as outputs. And we begin our serial ports. So remember I said that it's important to remember the speed, your baud rate from your ESP. Well, that's where it comes into play here. So we have the serial 1, so this is the external serial line on the Teensy, and that's the serial that's connected to the ESP module. The serial.begin is actually on the Teensy is dedicated to just computer communications. And I'm not actually really using it in this program, but I figured I'd have it ready to go in case I wanted to drop in some lines of debug or even just have it print out the current state of things to the screen. So this one isn't strictly necessary, but I have it in there for good measure. And then here's everything that happens in loop. So the first thing that I do is I make sure that if we have any serial data, that we peek and we look at it. And I want to make sure that our first character, the first byte in our serial line at all times, is one of our headers. Because if it's not a header, if it's not one of our valid headers of either D for door or T for temperature, then I can more or less assume that it's just garbage data. You know, I'm not going to be able to parse it out if I don't have my header, so I basically just check to see if it's not equal to D and not equal to T, I just read it, and I take it out of the buffer. So at that point then, we now check to see if we have serial available, and we have more than or equal to 2 bytes. So remember, our packets are 2 bytes in size. Well, I don't want to read if we only have 1 byte of the packet, so I just wait until 2 bytes have come in. And I set the header byte, I read it, and I set the header byte, and I set the payload byte. And then for the door, it's pretty simple. If the header was D for door, and the payload was 1, I turn it on. If it was 0, I turn it off. Pretty simple. The temperature, it looks more complicated. It's not. There's probably a more elegant way to write this, but I just haven't felt like dealing with that. Basically, we check to see if our header byte was a T for temperature. And if it was, if our payload is more than our high temp, which we defined up here, our high is 72 and our mid is 70. If it's more than our high temp, we turn on the high temp pin. And else, so it's less than high temp, but it could still be more than mid temp. We turn on the mid-temp pin, and all other cases we turn on the low-temp pin. And for all of these, the other pins are just turned off. So it's actually really simple on the Teensy side. All the complex stuff of handling networking and MQTT, that's all handled on the ESP modules. So now that we see how this is actually taking in data and processing it, let's check out the code for our nodes. So here we have the temperature node, the temp node. And this has our pub sub client and our Wi-Fi library. And then we also include the OneWire and Dallas temperature libraries. So that little temperature sensor is actually, it communicates via the OneWire protocol. So we include those libraries, and then we create a OneWire instance on pin 2 and connect that instance to our Dallas temperature sensor library here. So that gets us kind of set up for our temperature sensing, at least hardware-wise. And, of course, your server IP, SSID, password, you guys know this at this point. And then we have our temperature topic. So this, unlike the conduit node, this is actually going to be publishing to this, and the conduit will be listening. And then we have a character array of 2 called current temp. I'm going to get into exactly why we have an array here versus just a single character, because really we are just sending 1 character, but I'll explain why we have that. So we set up our client and all that, and then so here we have our current temp of 1. So this is actually the second spot in our array here, and we're going to set it to basically null terminate. And we do this because if we only had 1 character, we're only trying to actually send 1 character, but if we only had 1 character, the publish function that we're going to pass this array to is actually looking for a character array, a string basically. And it will only stop reading bytes after it gets to a null terminated byte. So if I don't have the next byte directly after our temperature be null terminated, it's probably just going to read a whole bunch of memory and spit out a whole bunch of garbage that I don't actually want it to do. So I made an array of 2, set the last byte in the array to a null termination character, and that takes care of that. And you'll see that in action a little further down. We start up our serial line, and we start up our Wi-Fi. Again, serial actually in this case is not really used. We just have it there for debugging. And we attempt a connection. After we've connected to our Wi-Fi, we actually have this little line here. This is a new one. This is for our temperature sensors. It just starts up the Dallas temperature library, basically. And then our loop is pretty simple. You know, we've seen this bottom section before. It's just make sure it's connected and run the client loop. And then we have a delay of 5,000 in here. So this is actually because I want to only post a new temperature once every 5 seconds. So rather than have it post every 10 milliseconds, which will just put undue strain on everything, I have it post every 5 seconds, and that's plenty fast. And actually dealing with the temperatures, we first send a command to the sensor itself to take a new reading, because they don't just continuously take readings. You actually have to request a new reading. And then we get the current temperature. So we grab a float of the temperature. So this is the 0th indexed. I only have one sensor, so obviously it's going to be the 0 index. And we set that to current temp float. Then after that, we take our current temp, our first byte, so the second byte we set up before to a null termination. Our first byte here is going to be set now equal to current temp float. And yes, I know this isn't really the best way to do it. It's a float and I'm putting it into a byte and it's just going to truncate, but that's fine. I don't really care about resolution here. I just want to have a general idea of the temperature, plus or minus a degree. And then we publish that to the temp topic. We take our current temp array and we publish it to temp topic. Very simple. Quick, does it, and it all works. So the last thing that we have to take a look at here is our door node. So this is the one this is the ESP module that is connected to the read switch. So again, you got all this is pretty self-explanatory at this point. Connect to your network. We have a pin 2 that our read switch is connected to, and we have a variable here called isOpen, which basically just keeps track of whether or not the previous reading or the previous time that we did something, it was open or closed. And that way we don't just spam the MQTT port with open, 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 or close, 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 closed. It only just sends it once, when we open the door and when we close the door. So it just keeps down on network traffic, really. And our door topic that we publish to. Set the door as an input, door pin as an input, start the serial line. Again, we're not really using it. Start up the Wi-Fi and make sure that we're connected to Wi-Fi and the MQTT server. All right, so here we have our loop, and the first thing we do is we grab our door state. So we read our door pin and put it into door state where low is closed and high is open. And then we have 2 if statements. One is checking to see if the door was open, so if isOpen is true, and the state is closed, so not door state, we publish that the door is now closed, and we mark it as such. And we put a little delay in there just to keep things running smoothly. And otherwise, the door was closed and now it's open. So we publish that we have opened it and we mark that down as open. And we delay again. And then down here is just very simple, just, reconnect, loop, and delay. So nothing big there. So that's all the code that there is that runs this whole system here. It's pretty simple. The 2 nodes are pretty simple. Even the ESP conduit that's handling all the MQTT and translating it into the serial commands, that's all pretty simple too, and the Teensy's simple. So you guys should have no trouble getting this up and running in just, an afternoon if you wanted. And this gives you the foundations you can have as many temperature nodes as you want and as many door nodes as you want. So you can now wire up your whole house. In future episodes, we're going to take a look at how to take your temperature and actually hijack your home heating system, your HVAC system, and control it via all these nodes. So this is a great start to a whole home automation system. I know the first couple episodes have been kind of dry. There hasn't been a lot of actual real use to get out of it. I guess controlling your light is useful, but now you also have the ability to take readings from throughout your house. So yeah, I hope you guys have been liking this series. If you do, definitely like and subscribe to my channel. You can also find me at my website, ItKindaWorks.com, and also on Twitter at ItKindaWorks Inc. So I look forward to hearing from you guys. Definitely let me know what you think in the comments, and I will see you guys next time. Take it easy.